Hello, dear conference participants. Today, my dear colleague PhD candidate Mustafa and I, Selen, Çiçek, master's candidate in Istanbul Technical University, will present our recent research named as Urban Map Generation in Artist Style using Generative Adversarial Network. As the recent developments in the field of AI and machine learning explorations help the designers, architects, and urban planners, it is possible to generate novel outcomes for the future projections of the urban tissues. Or it is even possible to implement the possibilities that have never had a chance to be projected in the urban environment of the contemporary cities. So the initial query of us started by thinking on the second one, and we asked the first question as, what if the well-known artist who was the pioneer of a certain artistic movement had a chance to express their styles on the urban map? Artists produce artworks in many corners of the cities they live in or they visit. However, many of them have not found a chance to express the plan of that city with their own style. One aspect of this work within the scope of the machine learning exploration is to show what a city plan would look like if it were tried to be represented in the style of an artist, which can be further used in creative visual environments as a database, for example, a level design for the game industries, or as an NFT art collection. Thus, we have trained two different GAN algorithms of cycle GAN and style GAN and explored the possibilities of reinterpretation of stylistic urban maps. Besides, we have also discussed about the potentials and disadvantages of the usages of two different image-to-image translation GAN models. As you can see from the flowchart, our research process has begun by collecting two main datasets of urban maps and artist paintings. For both datasets, we have used certain data acquisition techniques to retrieve the images from the web and applied batch image processing operations to produce proper datasets for the training to image GAN models. After collecting the datasets, the GAN models have been trained with their inherent computational network that will be explained later on. The test results have been presented and discussed about their eligibility in terms of representing urban map characteristics elements of the contemporary cities. To collect the urban map dataset, we used an open source API to produce a map template for batch retrieving the urban map images according to the defined square meter area. After the related images have been collected, the images have been subjected to a batch processing operations to have them in 256 by 256 pixels in square RGBA formatted PNG files. The important parameter in this step of the process was the selection of the cities to represent different urban texture characteristics. Therefore, we selected the 5 most populated cities of the countries that show a variety of urban morphologies due to their geographical locations. Here, you can see the instances of the urban map dataset in terms of variety of morphological characters inherent in the maps. The second dataset created for the machine learning exploration was the artist paintings. In order to apply different artist styles to urban layouts, we collected the data from the CycleGAN repository. The selection criteria for the artist paintings, besides the availability issue of the data, was the artistic movements that they are belonging to. The artworks of well-known pioneer artists of the Impressionism, who were Van Gogh, Monet, and Cezanne, have been included in the dataset, whereas Ukiyo's paintings has been consciously added to the data from the Japanese style, which has strong connections and influence on the Impressionism in order to embrace the complexity within the dataset. The selection of the Impressionist artworks was critical at that point of the research, since the movement pioneers generally depicts the landscape and the contemporary life by the capturing rapid pace of the light and the fleeting conditions of the light. Thus, that kind of constant transformation represented on the artworks has been elaborated conceptually as a similar manner of the urban fabric, which is constantly subjected to alterations within different time frames. Then, all painting datasets containing the artworks of the artists have been subject to a series of batch image processing operations.
This cycle GAN is a technique that involves the automatic training of image-to-image translation models without paired examples and unsupervised learning. It is used to train the models using a set of images from the source and target domains that can be unrelated. The system can learn to capture features of one image collection and find methods to translate these features to other image collections in the absence of paired training examples. By including an extra loss to calculate difference between the output of the second generator and the original image, and vice versa, the cycle gap promotes cycle consistency. As a result, the generator models are regularized, directing image production in the new domain in the direction of image translation. The style GAN is a GAN extension that proposes significant changes to the generator model. These changes include the use of a mapping network to map points in latent space to an intermediate latent space, the use of the intermediate latent space to control style at each point in the generator model, and the addition of a noise as a source of variation at each point in the generator model. In this technique, a feature space that was initially created to capture texture information to get a representation of the style of an input image is employed. The filter responses in each layer of the network are used to create these feature space. It consists of the correlations between the various filter responses over the feature map spatial area. A stationary multi-scale representation of the input image by adding the feature correlations of many layers, which captures the texture information but not the global layout, is generated. The model initially trained with 60 epochs on the Google Colab platform. After the generation of first sample images and plotting the discriminator losses on the chart, the application continued by training it with 6,000 epochs values. However, while training the model with 6,000 epochs, we faced an interruption in the 5,560th epoch due to the working time issue of Google Colab. The total discriminator and generator loss values in the 10th and 5,560th epochs of the application are given in here. Likewise, in Van Gogh's painting application, the model was first trained with 100 epochs for the first try. Then we have trained our model using the same hyperparameter as the previous application, but this time with a smaller number of epochs of 4,000 to see the difference in between. The discriminator and total losses of the 10th and 4,000th are given here. When we try to evaluate the outputs of cycle GAN models on the same urban dataset applied with two different sets of Van Gogh and Monet paintings, it's possible to say that the map-to-painting conversion had provided successful results in terms of legibility of urban characteristics. The style GAN model was trained with 10 epochs and 1,000 iterations for each epoch. The loss of the system has not changed drastically with different parameters. However, visual results seem promising. The algorithm is run with painting to map transfer initially. After trying the painting to map, the algorithm has run in the opposite direction and transfer map to painting to see the results. Even the system loss has not changed significantly. The results can be evaluated as promising stylistic map features. The model is trained with the same parameters in every trial to see the differences. The losses were plotted similarly to previous training session. Map to painting has run and losses achieved similar to Cezanne example also. The last exploration was from Van Gogh dataset and the system loss results were similar to other attempts. The algorithm was run with 10 epochs and 1,000 iterations for each epoch as previous attempts. The losses are similar to previous attempts. After many failed attempts, generative adversarial networks successfully learn and generate urban plans with chosen artist styles. By training datasets of different styles, various results have been achieved. In the context of the results, we believe that the model mapped to painting with cycle GAN algorithm is more promising GAN model in terms of introducing a new type of representation, where you can see various artist touch in today's modern urban plans. Therefore, it's possible to say that it enables the user to generate map images that look like an aerial view, which are painted by an avant-garde artist from basic figure ground maps of the cities. Secondly, the painting to map outputs of the style GAN also values a lot, especially for the future research directions in terms of generating new urban patterns in artist style. However, in the style GAN algorithm, the system does not train the whole paintings of the artist to apply the style to the map. It rather learns the style of the given painting and applies it to the map. So rather than producing maps in an artist style like in CycleGAN, it produces maps in painting style. The generated painting to map images can provide a basis for further research agendas, which focus on the inquiry about the potentials and drawbacks of applying this methodology as a tool for urban planning applications.
These
These are
were our
references.
valuable sources that we use during the research. And
Thank you.
thank you.